think it's recording. We'll find out later. All right, so more on basics of fractions. We went over the different ways to model fractions, and just a little bit on terminology and a few other facts. And then we'll play with toys some more. So whenever we have a fraction like 2/3, whether we use the horizontal fraction bar or we use the slash fraction bar, right, those are two different ways that we write fractions. A fraction is made up of a numerator and a denominator. So 2 is my numerator, and the 3 is what we call the denominator. So numerator is a noun for another, the idea, the action of numeration, right? And what does numeration mean from last quarter?
Number.
It means number, and what does number mean at its most basic level? What's the first thing we do with numbers? Count, right? We count them and then we end up adding. Yeah, so numerator just means to count, okay? So it's a count of how many. Denominator comes from the word denomination. Have you heard the word denomination before? If so, in what context?
In church.
Yeah, different religious denominations, right? My mom was Roman Catholic, my dad was Protestant. That didn't go over well with each family because they view each other as different religions, right? The different ways they describe themselves, okay? Other places people have heard denomination besides religion. Politics, you can have a political denomination like Democrat, Republican, Independent, Green, okay? Where else? Money? Everyone ever heard bill denomination? So bill denomination, like a $1 bill is worth $1 and a $5 bill is worth $5. Yeah, so there's also denomination of money, okay? And that's just a description of what it is. So a denominator is a description. So this is based on the model of equal parts of a whole for a fraction. The number line model or the model where we look at a ratio is a little bit different. Okay? So here we have two things. What are those things? They are thirds. Okay? So that's what's going on here. So I count two things. Those things are thirds. And so we could draw that. Popular way in books to draw fractions is with a circle. I refer to that as a pie diagram. Versus you could make yourself a square cake. And I prefer to do cakes versus pies. I'm slightly better at drawing squares and rectangles than I am at drawing circles, which I think most people fall into that category. So either one of those can be my whole, and then based on those, I can try and estimate where thirds would be. And to do that, I could slice vertically or horizontally. So here I'm going to choose to slice vertically. And then what I could do is shade in two of those thirds. And maybe I'll shade those two for fun. So the numerator in this case is counting the shaded regions. The denominator is counting what each of those things is. What are those two things in this case? Well, they are thirds. You can do the same thing with pies. I find cutting thirds on a pie is a little trickier. Peace sign in this case. Cutting fifths is even harder. Sevenths, forget about it. And then I could shade in my pieces. So maybe I'll do this piece here. And this one here. Okay, so those both represent 2/3. As you'll see in a little bit, I prefer to draw cakes than pies, and I have other reasons why too, besides I find cakes easier to draw. Other things related to terminology. Page. There's the idea of a proper fraction. If a fraction isn't proper, what is it?
Improper.
Improper, which seems like a bad thing. Like whenever my parents called me improper, I knew I was in trouble. But having improper fractions doesn't mean trouble. It's a good thing sometimes, most of the time. So can somebody give me an example of an improper fraction? 3/2 would be an improper fraction. Yep. How about a proper fraction?
2/3.
2/3, beautiful example. How about, let's see, the number 3? Is that proper or improper?
Proper.
3. Improper? Why would it be improper versus proper?
Because we assume that it's 3/1.
3/1, yeah. 3 as a fraction could be written as 3/1. Now dividing by 1, nothing happens, so that could be more simply written as 3, but either way it's a fraction. Yeah, so all whole numbers are actually fractions divided by 1, and because the numerator is bigger than the denominator, it's improper. Okay? So there's a couple ways to think about proper versus improper. Improper fractions are greater than 1, if we just talk about positive numbers. Proper fractions are between 0 and 1. And you could argue that 0 is a proper fraction because 0 could be written as 0/1. So my denominator is technically small. My numerator is technically smaller. So that's the other way to think about it. So numerator is less than the denominator. Proper fractions are between 0 and 1. The numerator is smaller than the denominator. I lied. Oh, no, that's right. Yep. For improper fractions, you could say, well, they are fractions that end up being greater than 1, or they're fractions where the numerator is what compared to the denominator?
20%.
Almost.
Oh.
We missed one little piece there. Or equal to. Yeah, it could be equal to. Denominator. Oops, I missed. There we go. It could be greater than or equal to. Because if I had something like, so I guess I should put greater than or equal to 1. 2/2 is a fraction. It could be more simply written as 1. But 2/2 is a fraction.
But then 1.
And so we say that's improper. Proper fractions are less than 1. So just think about, when you think about the word fraction, don't you usually think of like it's less than a whole? I think that's a common belief people have. If I have a fraction of something, that means I have less than a whole. Like my mom made a cake, I want a piece of cake. She says, you can have a fraction of the cake. I don't think she wants me to eat the whole cake. Right? She wants me to eat less than the whole cake. So a proper fraction is less than 1. And then related to proper fractions are the idea of mixed numbers. And mixed numbers are related to improper fractions through multiplication and division. So think about a number line for just a moment. If this is 1 there, and that's 0, and that's 2 right there, then if I mark this off in halves, then this position right there is where I think 3/2 should be. Or I could say it's 1 whole and a half more. When we say things like this mixed number right there, we say, right, 1 and 1/2. When you read an improper fraction, does anybody ever omit the word and? Right? So if somebody wrote down that right there, we wouldn't say 3/1/4. We would say 3 and 1/4, right? Okay, and that's super important because that and is actually literal. This is 3 plus 1/4. This right here could be viewed as 1 plus 1/2. We literally mean add when we say that and. Okay, it's not just there because it feels awkward to not say it. Right? It feels awkward because we're used to saying it, but it's there for a reason, and the reason it's a literal plus. Okay? And we'll come back to that in just a moment.
But like when you're talking about that, of adding the 1 to the 1/2, how come when you like go back to find out how much it was, you times it?
We'll get there.
Oh, okay.
Yeah, slow down. You're slightly ahead of me, but I'm getting there. I guess I'll just do that since you brought it up. So what does it mean to do with that and there? So if somebody says, hey, what is 1 plus 1/2? Well, the rule, if you think back, what's the rule for adding fractions? Anybody recall?
Times the denominator by the whole number and then add the.
Times the denominator by the whole number. So you want to take whole
Wait.
times the denominator, and then do what? Add the numerator. Okay, so for me, that would be this one right here, times that 2 right there, plus that 1 right there. So that's going to give me 3. And then what do I do with that? I keep the denominator. Yeah, so I would take all of that and divide by the old denominator. So that would be 3/2, would be the way to write that. Okay. Another way to think about it is this is a fraction. That's really a fraction too. So I could say this is 1 over 1 plus 1 over 2. And the rule for adding fractions is you have to have a common denominator. What should the denominator be? 2. So that means we have to multiply this one here by 2 and 2 there. So this becomes 2 over 2 plus 1 over 2, or 3 over 2. Right? So there's a couple different ways to think about it. Right? This would be kind of the long version based on the definition of adding fractions. This is kind of a shortcut approach right there. So when somebody gives me 1 and 1/2, I envision this. I take this number times that number, and then I take the result and I add it to the top. I have this circle I do in my head to make that happen.
Isn't it weird how that always has to work? Is there an instance where it will never work?
It works. A short answer, it works because of the way we add fractions,
Right.
that you have to have a common denominator. Okay. The next question is, why the heck do you have to have a common denominator? We'll get to that question in a minute. But because you have to have a common denominator, this process always works. It's a shortcut of the method above, is what it is. Okay. So going the other way, so that right there is conversion. Let's go blue. This is to convert mixed to improper. Long way, you're adding fractions. Shortcut is you have this little circle route that you follow. If you want to go the other way, if you want to convert a improper fraction to mixed, then you have to divide. So easy example here, 3/2 can be written in a few different ways. It can be 3 divided by 2, like a fraction. It could be 3/2, alternate fraction. We could use the division symbol, which is this funky thing right there, 3 divided by 2. Or we could go really radical and use the goes into symbol, where we say 3 goes into 2. Oops, I wrote that backwards. Sorry, 2 goes into 3. So how many times does 2 go into 3? Once. 1 times 2 is 2. Subtract and I get 1. So before fractions with kids, we would say, hey, 2 goes into 3 one time with a remainder of 1. Now that we have fractions, we say it goes in, what we're saying is 3/2. 2 goes into 3 once with 1 out of 2 left over, is the new way we have to write it. That's what long division tells me.
The first time?
No. 2 is going into 3 here. And that's what this says. 2 goes into 3.
Oh,
Right? Because 3/2 does equal 1/2. We decided that reverse on the other page. That 1/2 equals 3/2.
okay.
We'll flip that next chapter. Try to
Okay.
take 3 into 2.
Okay.
Yeah, so just test this idea on another fraction. Suppose we had 7/3. What is this as a mixed number? Now, sometimes we
2
can
and
just look at
1/3.
these and do it in our head. 3 goes into 7 how many times?
2.
2.
2 with 1 left over. So 2 and 1/3 would be the answer. Okay. If it's not obvious looking at it, then just whip out your long division. 3 goes into 7 how many times? Well, 3 goes into, come on, pen. 3 goes into 7 twice. 2 times 3 is 6. 7 minus 6 is 1. So instead of saying remainder 1, we're just going to say it's 2 and 1/3. Where's the 3 come from? Right here.
Would it be wrong, like, why aren't we taught to do the remainder as what's left over plus the whole part of it, so like a 1/3?
So why
remainder
not just
1/3.
jump straight to 2 and 1/3?
Yeah,
Um,
to learn, like, since I know, like, in elementary we didn't learn that, we're
Yeah.
probably learning it now.
So
in a sense.
most kids would just have a really hard time with dealing with fractions and these whole number things at the same time.
Okay.
Some kids can handle it, but I would say more than half of your kids, so you're going to do this in like the long division in say 3rd and 4th grade, the fraction result is going to be a little harder for them. Could you train them to do it? Yeah. You
And say,
could.
like, you, like, still teach them remainder, you have them remainder
Yeah.
1, and then
Yep.
you divide it by.
You could just say another way, yeah, so you could just list it this way. 3 goes into 7.
I mean,
2
'cause eventually
times-
that's something we all have to learn, and why not get used to it, like, at a younger age, if that makes sense.
Yeah, and if you look at history of curriculum, ideas get pushed down to lower and lower grades all of the time. This happens constantly. Yeah, so those are the 2 different ways to document the result there. And I think you could kind of get away with doing that, and most kids would be okay with it. All right, so let's see. Next, we're going to take a look at some fraction comparisons. So super easy one, 1/2 versus 1/3.
1 is smaller.
1 is smaller, yes. So did I put these in order? Are these smallest to largest? Okay. So some kids have a hard time with that because they would say, well, 3 is bigger than 2,
Is that why like number?
right? So the way to think about it is, well, remember, what is our denominator? It's a description, right? Our numerator is a count. So a fraction we're looking at as a count over a description, okay? So I want to show that description to somebody, and I might do it by drawing cakes. So I could draw a half a cake. And for the half, I'm going to draw that a vertical slice and then shade it. And for the third, however, I'm going to draw those slices horizontal, and I'll explain why here. So I do my best slicing it into thirds, and then I pick one of those thirds. These are not the same size pieces, agreed? If this was cake and you really wanted a lot of cake, which piece would you pick, the half or the third? The half, right? So this picture, it looks pretty clear that 1/2 is greater than 1/3. Okay? Sometimes it's not always obvious. The trick when they're cut different is to cut each like the other, if they're not cut the same way. So what that means is take the half cake and cut it into thirds also, and take the third cake and cut it in half. And the reason I do one vertical and one horizontal is because it makes the cutting easier, so they're comparable. Now, how many pieces are in a whole? 6 pieces. So this piece right here could be called 3/6, and this piece right here could be called what? 2/6. So now I have the same description. They're the same size pieces. So which is bigger, the one with 3 pieces or 2 pieces? If the description is the same, yeah, the 3 has got to be the one that's worth more.
Okay, so that was gonna be my question, because one of the homework questions was kind of like that,
Yep.
and it had like 10, 15, 25, or whatever. Does it work to change the denominator
Mhm.
to like the same number on
Yep.
all of them? Okay.
Yeah, that's the way to do it. Yeah, because the denominator is a description. If they're different descriptions, how can you compare them? Right? They got to be the same description, which means you got to have the same denominator to compare fractions. All right, let's do another example. Suppose we had 7/9 versus
4,
17/20. Don't want to draw that one. Okay, so I'm going to look at the back other one for inspiration. So this one right here, two things happen. This one piece got cut into how many pieces? 3. Why 3? Because this one was cut into 3 pieces over there. So what happened here is this 3 down here basically got multiplied over to there. And this 2 multiplied over there. What's 3 times 1? 3, and 2 times 1 is 2. I'll show with a simpler example in a minute. So my belief is that if I apply a similar thing here, 20 times 7, 140. 9 times 17, ooh, that's a harder one. That would be 90 plus 63, 153. If I did that right? Which one's bigger? The 153 should be bigger, so that means the 17/20 should be greater. So I could put a less than in between. The 7/9 has to be smaller. Another way to think about that, 7/9 versus 17/20, is I need to have a common description to make them the same. So the easiest way to find a common denominator is to just multiply your two denominators together. What's 9 times 20?
180.
So basically what I want to do to this fraction right here, I want to multiply top and bottom by 20. And this fraction here, I want to multiply top and bottom by 9. So when I do that, I get a new set of fractions. This becomes 140 over 180. That's the same as 7/9. Versus this one over here is going to become 153 over 180. Since they're both 1/80ths, can you easily see which one now is greater? Yeah, 153 over 180 has got to be greater. So the shortcut is to just cross-multiply opposite denominator to numerator, and that gives you a quick comparison of the two fractions. Whatever has the bigger cross product is the bigger number. And it's basically finding common denominator. Okay, so this is what's called a cross product. And essentially what a cross product does is find you a common denominator. Okay, so we'll do one more example of that, and we're ready to move on. So let's try 3/4 versus 4/5. And oftentimes, based on your experience, you can kind of look at them and guess, but it's good to compare that, to kind of figure it out. So somebody might say, well, the one with the 4 in the top is bigger because there's more pieces. And somebody else might say, but fifths are smaller than fourths. Which would lead me to say, ooh, I don't know then. I have two reasons to go by there. So we could do the cross product, right? So I go over here and I say 5 times 3 is 15. 4 times 4 is 16. Is 16 bigger? Mm-hmm. Yeah. So it looks like 4/5 is bigger. It has more pieces. Even though the pieces are smaller, it still works out. Okay. Draw a picture. So let's draw a square underneath 3/4. And cut that one vertically into fourths. attempt to draw the same size square under the 4/5. To the best of your artistic ability. Cut that horizontally into fifths. That's a little trickier. Odd number is usually harder than even. But there's my best group of fifths. And then shade 3 of the fourths and shade 4 of the fifths. So you can't directly compare fractions that have different denominators, so physically what we do is we cut each like the other. So now I'm going to pick up my pencil again, and I'm going to cut the fourths the same way the fifths are cut. And I'm going to cut the fifths the same way the fourths are cut. And this takes practice. Some days are better than others. Monica, are you complaining about what you're drawing today?
Yeah.
Yeah, so then I look at this and I see with the 3/4, I see a 3x4 grid. No, what do I see? A 3x5. So that means I have 15 out of a total of 4x5, which is 20. And we learned, remember the area model for multiplication before? Over here, I have 4x4 for an area of 16 shaded versus 4x5 for 20 total. So I'm just showing again, the cross multiplication finds us a common denominator. What common denominator does the cross multiplication find? It always finds the product of the two denominators. Is that always the best way to go? Answer is the fastest way to go. It's not always the best, which we'll see in a little bit. Okay, so let's take a look at a homework problem that came up. One of the homework problems at the end of section 5.2 was given two fractions, find 3 in between. See you later, Jimmy. And so I'll show you a couple of different ways to think about that. And I'm going to pick a different pair. Let's go between 1/8 and 1/9.
Why?
So step 1, make a number line. On the number line, I don't care about any other numbers but 1/8 and 1/9. So here's my number line. Oh, by the way, which one's bigger and which one's smaller here?
1/9 is smaller.
1/9 is smaller, so I draw that first and then the 1/9 second. And leave a bunch of space in between. So one way is to say, well, I could find the middle number because I know how to do an average. Do you guys know how to do an average? How do you average two numbers?
Add and then divide.
Add them and divide by 2. So the middle number there is going to be 1/9 plus 1/8 divided by 2. So let's do that for fun. Let's see. 1/9 and 1/8. I got to find a common denominator, which is, any guesses? No. 72. Why 72?
Because when you times
9 times 8. Yeah, 9. The easiest denominator is 9 times 8. And it turns out there's no smaller denominator than that you could use. Yeah, so the denominator I need is going to be 72. And to think about that means I have to multiply 8 top and bottom here, and I have to multiply 9 top and bottom there. So that means I'm going to have 8 over 72 plus 9 over 72, which altogether is going to give me 17 over 72. All the while, that has to be cut in half eventually. So that means I'm dividing a fraction. Anybody recall the rule for dividing a fraction? Multiply by, not 2, but 1/2. Yeah, you flip the second fraction. So this is going to be the same thing as 17 over 72 times 1/2, which gives me 17 over 144. That is the number that's exactly in the middle. So at first glance, finding the number in the middle seemed like a good, easy idea, but it was actually a lot of work, wasn't it? Yeah. But I could do that again. Couldn't I find the number in between those two right there by averaging them? Yeah. Okay, and then I could find the number in between there, and then I could find the number in there, and in there, and in there, and I keep cutting things in half. That's one way to do it. Here's an easier way than that. You could do that all day long. It's good exercise in working with fractions. So maybe you want a clean picture, 1/9 and 1/8. You got to have a common denominator. You cannot get away from that if you want to find fractions in the middle. Okay. So what's the common denominator again? 72. So this would be 8 out of 72. And this would be 9 out of 72. Okay. What's in between 8 and 9? Well, there's no whole numbers, right? So 72 isn't a big enough denominator to find stuff in between. Easy way to make it bigger, multiply by 10. Make it 80 over 720 and 90 over 720. Aren't those still 1/8 and 1/9? Okay, can you give me a fraction somewhere in the middle now?
81 over 7.
Yeah, 81 over 720, that would work. How about 85 over 720? That's somewhere over here. Would that be in the middle? Because it's between 80 and 90. What if I write down a fraction and I'm not sure? Like I write, let's say 87 over 720. But what if I made a mistake and that's really on the other side? How do I double check that? Didn't we just come up with a trick for checking to see if one fraction is bigger than another? What was the trick to check? Yeah, do the cross multiplication. You could take the 8 times the 87 and the 720 times 1, and the number on the left better have a smaller than the number on the right. Yeah, so you could find ways to check it. There's many other ways to do this. Those are just 2 ways. So, and this question isn't looking for 3 specific fractions in between, any fraction in between. So suppose you were worried 720 wasn't big enough. Well, multiply by 10 again, right? Make this 800 over 7,200 and make this 900 over 7,200. There's a whole bunch of numbers between 800 and 900 with 7,200 as the denominator. And they will all work. The computer will take anything in there. Okay? What if instead I had asked you to look in between these two? Could you zoom in again?
Mm-hmm.
Yeah, same way. Yeah. Multiplying by 10 again, that would be zooming in to find more numbers in here. So like sitting right around right there would be like 802 over 7,200 would live right in between there. Yeah. So fractions are weird. They're not like whole numbers. In most things we do in our life, we don't need a lot of those fractions, but sometimes they come up. And then we have decimals to deal with too. All right, let's get started on activity 5.2. So that's about all of the stuff